Okay, this video will show you how to find the z-score of data points and then do some calculations on finding percentages and things about them. So remember, a z-score though is the data point minus the mean, and then that difference is divided by the standard deviation. So we need the mean for the height and the standard deviation for the height. So I have 25,000 heights of 18-year-olds. And they're rounded to the nearest inch, so that makes it nice and easy. So I need the mean and the standard deviation. So I come over here and I write average equals average. That's the function for mean, the average. I click this one here, and I can't, if I want to drag down 25,000 spots, it's going to take a while. So I click the first one. It tells me it's in the B2 column. I know that I'm going down 25,000 spots, and I've got the first column or first row used, so I'm going to colon 25,001 to the 25th, the first 25,001 spot, right? Oops, looks like I didn't put the B in there. So it's giving me an error because I need to tell it what column it's at, B. B 25,001, and it's highlighted them all. So if I scroll down, we can see that this has highlighted everything. Perfect. Okay, so that's the mean. Now we'll go with the standard deviation, hit equals STDEV, and then parenthesis, same kind of idea. We'll hit the first one, it's in the B2 column. I'll do colon and do B 25,001. I should get them all, right? There it is. So we have the mean and standard deviation. Now we're able to build that z-score. Equals the data point, whoops, I need parentheses because I need to have that difference, the data point minus the mean, parenthesis, divided by the standard deviation. Hit enter, and there it is. Now I want my standard deviations to be rounded to, so I right click and then format cells, number to 2 decimal spots. Negative 0.104. Again, I can't drag this all the way down, and I have to be careful, as if I do drag, look, division by 0. Let's go back and look. The B2 cell is here, and then the F1 and F2 are over here. When I drag down, they move. The B3 moves down like I want it, but look, these moved down. I don't want that. So what I got to do is I got to go back up to the top one, and I actually have to put some dollar signs. Dollar sign just tells Excel that you need to stay looking at those cells. Notice I put it in between the F and the 1 and the F and the 2. So now when I drag down, it stays looking at those cells. Those didn't move, and this one did. So once you got that down and you've drug it one time, highlight those two, and then a quick little thing to do is go to that little square and double tap. Left click twice, and what it does is fill the whole thing for you. Perfect. Awesome. There we go. We have all our z-scores. And then you could ask anything you wanted for values or whatever you want. So let's go over here and try this one. Z-score less than 1.08. So it's not on the list. It's just a practice. I have a z table. We want 1.08. So I'm looking for the 1.0, and then I'm looking for the, on the top here, going across the 0.8. So this is just showing that third digit, 0, 1, 2, 3, 4, 5, 6, 7, 8. It's right there, 1.08. 85.99, 0.8599. That means 85.99%, or basically 86% of the people are less than 1.08 or whatever it is, or z-score, whatever that z-score is, right? Because this, remember, finds the area to the left, probability to the left. So that was a practice one. Here's a question here. Let's just kind of move this down a little bit. What is the percent of people that are shorter than 66 inches? This one's not right. What's the percentage of people shorter than 66 inches? Well, what we do is we go over here and maybe find 66 inches, or we actually figure it out with this formula, right? Find the z-score. But luckily in my list here, my rounded off list, I have a 66 inches. It's right here. So 66 inches has a corresponding z-score of negative 0.104. I go to my table. I find the negative 1.04, negative 1.0 right there, and go to 4 now. 1, 2, 3, 4. Find where they match up right here, 1492, so 0.412. 0.4192. Oops, it's in for some reason it's showing a percentage here. Make sure that my things are formatted for decimals. Number, I'll give it some decimal points. 0.4192, or sorry, 1492, right? 1492. So that's corresponding to 14.92% then, right? Of course, now it doesn't want to do percent, so I got to format back to percent on that one. Perfect. Now, what that means is that there are 14.92% of people that are shorter than 66 inches, right? So not a lot. It's to the left of the mean, so there shouldn't be very many. What about, what's the probability, or is the percent of people that are at least 71 inches? So the probability that people are at least 71 inches. So let's find somebody that's 71 inches so I can find their z-score, or just calculate it. I see it's 1.56. Now remember, the table finds the area to the left. So I need to find the 1.56, 1.56. This is the area to the left, right? See the z? If I want to find the people that are at least 71 inches, I'm talking the people that are greater, to the right, 72, 73. So I find this 1.56, which is 9406, 0.09406. And what I do is I take and I subtract it from 1. 1 minus, so I'm doing an equal, so I'm doing a little math, equals 1 minus that cell. And that gives me the answer in terms of to the right. So 2 decimal places, 5.94%. Okay, so look at this again. The at least 71 inches means you're more than that, right? You're at 71, 72, 73. So I go find what 71 inches is as a z-score, 1.56. The table shows me 1.56 as an area to the left. I need to find that area to the right. The whole thing is 1, so I subtract off my shaded area. 1 minus that will give me the area to the right. So that's 1 minus that. That's my 6% of the people are at least 71 inches. Now the in-between. What are the probability that someone is in between 70 and 72 inches? So again, now here we're going to have 72 inches is the bigger number, and then 70 inches is going to be here, right? So what we're going to do is take and find the 72 inches, which would show me the left, and then we're going to subtract off the 70, and that would be to the left that way, leaving just the middle portion, which is the in-between. So let's find a 70. There's 70. And then let's find a 72 right there. So for 70 and 72, the z-score for 70 is 1.04. The z-score for 72 is 2.08. Quite a difference, right? Now let's find the area to the left of each of those. So the area to the left of 1.04, 1.04 is 8508. And the area to the left of 2.08, 2.08 is 9812. Now what we're interested in is the in-between. So we're going to take an equal sign and take this number and subtract the lower side, and that would give me the in-between. So we're looking at 13.04% of the people are between 70 and 72 inches. Now remember why we did the subtraction is because they're finding areas to the left. So the area to the left of the 72 would be here. The area to the left of 70 would be approximately here. So subtract off that 70 from the 72, leaving the in-between. Okay. So hopefully that was a quick lesson on how to find a z-score and then how to answer some questions based on z-scores. These are just z-scores. They're not based on mean and standard deviation of the actual data. If I wanted to do that, I could. So for example, let's just do this first one. What is the percent of the people that are shorter than 66 inches? 14.92%. Well, Excel has a function for that. Equals norm.dist. And I could have just went over here and said, okay, if I want to find the area to the left of that z-score, I know it was 66 inches. I didn't have to do the table. I could just do norm.dist and type negative 0.104 for my z-score. My mean would be, when I'm standardized like this, my mean is always 0, and my standard deviation is always 1 when I'm standardized. And true. And that's the reason why we're using 0 and 1 is because we're using a z-score. We're not using the actual 66 inches. So I hit enter. And there's the same probability. Now, Excel can actually do it for you from using your 66 inches. Equals norm.dist. Put in your x value of 66 inches. Put in your correct mean value of 67.9942. Put in your correct standard deviation. Notice I'm using inches this time. I'm not using z-scores. 1.9233. Then hit true. True means that we're using the whole graph to the left. This is only giving your answers back to the left, remember. Area to the left. It's a little more accurate. Okay, 14.92, 14.99. This is a little more accurate because we are not using a rounded off table. The rounded off table only goes to 1.31, for example, only goes to 2 decimal places. This is using all of the decimal places that we have up here. So this formula, the norm.dist formula, it finds the area to the left of those values. You have a data point, a mean, and a standard deviation. And when you're using a z-score as your data point, your standard deviation and mean are standardized. We have a mean of 0 and a standard deviation of 1. So be careful what you're putting in there if you're not going to go through the process of using the table with the z-score. Okay, good luck.